In ester hydrolysis, remember that an alcohol and a carboxylic acid is produced, and therefore it follows that for a triester hydrolysis, the ester link is broken here, and since it's a triester, 3 ester links are broken to produce 3 moles of acids. Since this is the salt of the acid and it's under acidic conditions, therefore the protonated acid is formed, and there is the formula of protonated acid. And the other molecule that's formed is propane 1,2,3 triol or glycerol, because remember that fatty acid is made up of, a fatty acid or a triglyceride is made up of 3 fatty acids or carboxylic acids and 1 molecule of glycerol or propane 1,2,3 triol. In this question, many students were bombarded by the fact that catalysts are meant to speed up a reaction, but this wasn't the answer to the question. In all free radical mechanisms, the free radical actually combines with one of the reactants, and therefore a side product contains the oxygen, and therefore the free radicals are used up. In real catalysis, the catalyst is regenerated. So in this case, the free radicals are not regenerated. They actually combine. So they're actually used up. So the next part of the calculation is pretty straightforward, because you're given a mass and you're given an MR. So your immediate response is to calculate the amount or the number of moles, which we know is the mass divided by the MR, and that is equal to the amount of fat that was hydrolyzed. Now, if we now go to look at the carboxylic acid, again we've been given a sodium hydroxide, which will react with the 3 moles of the carboxylic acid produced. So therefore we know the total moles of acid. So the total moles of acid, of fat that were there at present, is 0.03449, and the total moles of sodium hydroxide that reacted with the acid was 0.00375. However, the ratio of fat to acid is 1:3. So if we divide the moles of acid by 3, we'll end up with the moles of fat that was hydrolyzed. So once we know the amount of fat that was hydrolyzed, which is 0.001225, notice I've not rounded up to 3 significant figures, we have the MR and we have the amount, therefore we can now work out the mass of acid that was hydrolyzed. So there's the amount, number of moles, times by the MR, and that tells us the mass of acid, which is 0.987 grams. So to get the percentage hydrolysis, we've got the mass we've calculated and the total mass of fat we started at the beginning, and therefore we divide 0.987 by 2.78, that's the original mass of the fat that we started with, we get 35.5% hydrolysis. 3 significant figures.